Okay, this is a quick explanation video on this question here, question 3, as part of the integrating parametric equations. So let's quickly read through the question to remind ourselves what it is, and then I'm going to go through my solution as a quick explanation, talk through. This graph shows part of the curve C with parametric equations x equals t plus 1 all squared and y is equal to a half t cubed plus 3. We're told t is greater than or equal to negative 1, and we're told P is a point on the curve where t is equal to 2, and to find that the line S is the normal to the curve C at P. Part A is to find an equation of S. So if we have a look at my solutions for that, we just summarise the key information here for our x and our y parametric equations. We know S was the normal to C at P. So the fact that it's the normal means that if I found the tangent at P or the gradient at P, then that would, I know that the normal is going to have a gradient that's the negative reciprocal of the gradient at that point, so negative 1 over it. So I know if I can figure out what a y coordinate and an x coordinate are at that point P, and I can find out the gradient at that point P, I can find the negative reciprocal of that gradient, and then use my y minus y1 is equal to mx minus x1 to find out what the equation is of the normal. So I can, knowing that t is equal to 2 at P, I can substitute 2 in as my t value into x and find that x must be 9. And I can do the same for y, substituting 2 in here, and find that y must be 7. So I now know that P has the coordinates 9, 7. I can also differentiate to find out what my dy by dx would be at that point. So dy by dt would be 3 over 2 t squared, and dx by dt is going to be 2 lots of my t plus 1. Pop in the comments if you're not sure like how we get those values there. But differentiating both of those with respect to t, that's what we get. Now dy by dx is going to be dy by dt times dt by dx by the chain rule, and I can find dt by dx by just taking the reciprocal of dx by dt, so it's going to be 1 over 2 brackets t plus 1. So in other words, my dy by dx is going to be 3 over 2 t squared times 1 over 2 t plus 1, and so that simplifies to be 3t squared over 4t plus 1. Substituting t equals 2 into that, I can find the gradient at that point, and beautifully it just works out as just 1. So the gradient at that point is 1, and so the gradient of the normal must be negative 1. All you need to do at the end of all this then, to find the equation of your normal, is to do your y minus y1 is equal to mx minus x1. You know the y coordinate was 7, the x coordinate was 9, and the gradient of the normal is going to be negative 1, and you get y minus x is equal to plus 6, y is equal to negative x plus 16, or y plus x equals 16. For part B, it asks you to find the area under the curve between when x is equal to 1 so we're trying to find the shaded region between x equals 1 and in this region here up to where above the x-axis. So let's have a look at how we could do that. So if we break this into two different sections, we could say we can find the area underneath the curve C up until that point P that we've just figured out by integrating between 1 and 9 with respect to x, our function y, and then we could add the area of the triangle that comes after that. So the area of the triangle is relatively simple, it's a half base times height. So we can know from the coordinates that the height was 7 and the base was actually the difference between 9 and 16, so that was 7 as well as it happens. So the area of that triangle is 24.5 units squared. The area underneath the curve between x equals 1 and x equals 9, we can integrate that parametrically by remembering that formula that the integral of y integrated with respect to x is the same as the integral of y integrated with respect to t, if we also multiply that by dx dt. So we can integrate with respect to t, if you remember this formula here, but we have to also remember to change the limits here. So this would be between 1 and 9. We could figure out what the limits would be in terms of t by substituting when x is 1 in to find out what t would be. We're told t is greater than -1. Greater than -1. So that must mean when x is 1, t is 0. And likewise, we can do the same when x is 9. But actually, in the question, we were already told t was equal to 2 when x was 9. So we've actually already been given that bit. We find our dx by dt earlier, which was 2 lots of t plus 1, that's the same as 2t plus 2. We know what our y was as an expression, so then it's just a case of starting off to expand this to make life a bit easier. So we get that we've got to integrate t to the power 4 plus t squared plus 6t plus 6 with respect to t, integrated with respect to t. Integrating that, we get this expression here. We know the limits are between 2 and 0, so we get a final answer of 34.4 for that, which we can add to our 24.5 and get that the area must be 58.9 units squared. I hope that made sense.